All right, guys, let's take a look at solving multi-step equations. Now, I made a video earlier about solving two-step equations, which is very similar. So I'm going to use a lot of those same concepts that I talk about all the time, really, when I'm solving any type of equation. So multi-step equations means we're going to have more to combine. So we could have two different sets of like terms, multiple things going on. So let's take a look at a good multi-step equation. All right, so if you've watched any of my previous videos on solving equations, I'm going to follow the same format. So I like to think of equations as having two sides, which they do. They have a left side and a right side, and I like to use my equal sign as the splitter, right? It's kind of the fence between the left side, the right side, and then the left side, okay? So first thing I always like to do when solving equations is to first see if we can combine any like terms the way the equation is originally written. Now, in order to combine like terms, those terms that are alike need to already be on the same side of the equation. So if we take a look here, we do not have any like terms that are on the same side of the equation. So we got a variable term here, and we got a variable term here, but they are on opposite sides of the equal sign. Okay, so we can't combine them until they get on the same side of the equal sign. We have a constant here, a regular number, and a regular number here, a constant. They are also on opposite sides of the equation, so we can't combine them yet. So we have to use some math trickery, right? We have to use some inverse operations to get those terms on the same side of the equation so we can combine them, and then eventually our overall objective is to get the variable, in this case the p, by itself on one side of the equation and then the constants on the other side. All right, so let's go ahead, and I like to get my variable terms on the left. So let's do that. So this p term right here, I want to get hit over here to be combined with that p term. So I'm going to have to mathematically get rid of it on this side. So I'm going to come in and subtract 5 p's. Okay, and that is an inverse operation, and those go away. 5p minus 5p cancels on that side of the equation on the right side. Now I can do that, right? But whatever I do to the right side of the equation, I have to do the left. So since I subtracted 5p's from the right side, I just created this, right? I have to do the same thing over here. So I have to minus 5p's on the left side. And I'll just conveniently stack it up underneath its other like term. Now we're going to combine these, right? We're going to take 13p's minus 5p's, and that'll give us a new p term here on the left side. But since we're already up here combining like terms and sorting them out, let's go ahead and sort out our constant terms in this same step too. Okay, so let's go ahead and get this constant term over here with this constant term. So in order to do that mathematically, I need to get rid of it where it sits right here on the left side of the equation. Okay, so subtracting 43 constants cancels out with adding 43 constants. So that gets rid of that term, but by the rule of equations, whatever I do to one side, I have to do to the other side. So I have to add 43 constants to this side as well. All right, so now let's work down. So we still got our equal signs, the fence here, right? We've got a combination of variable terms. That'll be our new term here on the left side. And our constant terms here will be the new combination here on the right side. And these canceled out, they're gone, that's a 0. And these canceled out, they're gone, that's a 0. Okay, so here on our left side, we've got to take our 13p's minus 5p's. That's going to give us 8p's. And on our right side here, we're going to take 11, that's a negative 11 actually, negative 11 plus 43 constants, and that's going to give us a positive 32 constants. And we're getting there, right? So remember, our whole objective is to get p by itself. We want to get p equals. So we've got all of our all of our variable terms combined here on the left side, and on the opposite side, we've got all of our constants combined. So we've got all of our like terms combined, and our last step here is to finally get p by itself, but p is attached to a multiplying by 8, okay? So in order to get that p released from this connection here, right, 8 times, p is being multiplied by 8, we have to undo this connection, right? So how do we undo multiplying by 8? Well, the opposite of multiplying is dividing, so I'm going to divide this side. That means divide, right? A fraction means division. I'm going to divide that side by 8. So multiplying by 8 cancels out with dividing by 8, right? They're inverse operations of each other, and that leaves us with p by itself on the right, or sorry, on the left side of the equation, which is good. That's what we want. But again, rule of the equations, if we divide the left side by 8, we have to divide the right side by 8 just by the rules of equations, and that creates a calculation over here that we need to do. So our next step, right, we work down, p is by itself now, and we got to take 32 divided by 8, and that's going to give us a positive 4. And finally, we've got our equation solved for. We figure out that p needs to equal 4. And if we wanted, the great thing about solving equations is if we go back to our very original equation up here and plug in our solution, okay, so if we take 4 and plug it back in for p, right, there's another p, and we plug 4 in and work this equation out, you'll end up seeing that the equation balances. The left side of the equation will equal the right side of the equation. So the great thing about solving equations is you can always check your answers, which is pretty nice. So there is an example of solving a multi-step equation using my methods. I hope this helps.